respected Dr. Rakesh Singh, Kale sir, and Hemant sir, and esteemed colleagues. If we are talking about composites, normally we are thinking about the products like lightweight technology from and this automotive, the satellites, then infrared antenna. But I have chosen a very different evergreen topic, sports, which is totally different. But there is a lot of scope from the composites. So I would like to express you about recreation. Why I use the recreation word? Suppose one person is coming in a crowded bus or Mumbai local train, then he takes the bath. He is feeling just relaxed, okay. But if somebody is coming with pump and show from the sports like football or any of the game, and he takes bath or she takes bath, they are feeling an enjoyment. So this is a psychological impact, but I am coming on the subject actually. My subject is this application of technical textiles and composites upon sports and recreation. Now, about this, naturally fibers like glass, dynama, carbon, then aramid, Kevlar, all are being used in everywhere, even in sports also, which I show you in the next slides. Then you see the process. So weaving, knitting, non-wovens, even braiding is also we can see actually used in the sports and everywhere. Even I will show you some videos also which I took at my tailor with Atira when I was building an incubation center and erected those machines. So everybody knows, but I want to add again, there are 8 TRS in the country and every TRA have an incubation center. So any student or professional, they want training, or any entrepreneur, if wants to do research and commercialization of the new products, are going to incubation centers, they are putting their demands, sharing of the technology and running it practically, unless they are not satisfied as a part of research and development, then they are doing the commercialization. So these incubation centers are supporting very well in the country. For Citra is for medical health, and Sasmira is for agrotech, Bitra is for geotech, then Nitra is for protection, then Digitech is for non-woven, PSC College Coimbatore is for industry, Atira is for composites, installation, and WRA for sports. So mostly this presentation, I was in WRA for some time in a conference, something like this, so I accumulated the material from there, and with the inspiration, I took the subject of WRA. Now, if you see this parachute is using for the satellite, also using for to coming down from the accident from the aircraft, as well as for sports. A person takes a lift from a vehicle, tying himself or herself, and attempt the flight on a very high, like 30,000 meter, 25,000 meter, like this actually, the pressurized. So what was happening? I am starting from the composite ropes and belts. So rope was only braided earlier, conventional ropes, but now woven ropes also coming. So when a trainee takes a lift with a jeep from woven rope, they can take 30-degree angle initially, while from braided rope of some hybrids from aramid or glass, they take a 45-degree lift, which is a very big achievement in this area. Then you see the sport shoes. Mostly polyester is the main contribution for this sport shoes, and you see most of the sports net is there, like badminton, like volleyball, like lawn tennis, every net is there. So these nets are made from the glass with epoxy or maybe made with the polyester with some treatment of resin like this. So here lamination and coating is also important, lacquer. Then you see these toilets. These toilets were made in 2013 in Atira from the glass fiber with epoxy. So these sides are from this fabric actually, 300 Tex glass fabric. And the front is the jute. There was toilets under PM Yojana of हर गांव में टॉयलेट होना चाहिए. So and also pollution parts are there actually. So with this export camp, they are also a part of the export actually. Then if you see this type of sleeping bags in outside sports, if players are resting, they must have a good sleep, a comfortable sleep. Mosquitoes should not be there. So there are many experiments actually. They are putting the fiber into the neem or organic way and getting such type of this type of bed. So mosquitoes are not coming. So there are many research on that actually. Then you see value addition on non-woven knitted and braided fabric. Suppose lamination coating has a importance. There is a lot of scope of technology because demand in apparel, bulletproofing, medical garments, anti-skid mats, lift shafts, construction, sports protection garments, automotive, because of lamination applications non-woven are desirable. Suppose we are saying in this composite bulletproofing. So bulletproofing cannot be completed without coating. Suppose we are taking the aramid biaxial fabric. So we have to put some 25 gram one side coating, some other side coating. Then we are testing in a forensic laboratory and getting the targeted results. So without coating and lamination, these things are not possible. So they have also a lot of scope in this, and they are value-added products we can make by this. Even belts can be laminated. Then further research and development is being put how to make their effective use. Then you see the cost-effective. Let's suppose you want to make the glove. The glove may for welding also. So for welding, glass gloves are sufficient, having the cut resistance. A glass is cheaper, so naturally fiber product is cheaper. But for some uses, you need some more 100% aramid these gloves. So what happens? For cost effectiveness, we are doing the blending. This is an example of the on loom for the aramid and glass hybrid fabric. Suppose your purpose has been solved, you have to reach to a higher temperature. Glass has extensive temperature, but it is costly. So it is not costly, but carbon has also very high temperature, but it is costly. So up to a part we can take carbon, then to reduce the cost, we can put the aramid also there. In a small way, in a more way what we write actually. So these are the hybrid fabrics, which can be used on hockey sticks like this, even gloves of the batsman like this actually. I show you. You see this bottom is the partition parts and the shade is the partition shade for glass partition. And above you can see the stadium. The stadium has a glass fiber sheet on the top. So in daytime, no need for tube lights or those things. Only from sunlight you can get the good air. Then this field is made of craft actually, artificial glasses. So development of pollution control, I already told you this thing. Then these are some accessories which can be made by composites. Then this blade table, pull table, they have also polyester wool or aramid wool hybrids. So they have no pilling tendency. They should have the, we are this very sweater in cold season. So pills are coming. So the pills should not come on this. So this wool as well as polyester mix up. it's spin free actually. So we can make this fabric in it. Then you see effect of, suppose you are doing the weaving of the rope. Rope normally we are talking of braiding. Two or three things or more things assembled among each other and making the braid rope. But now woven ropes are also available in which conclusion of core and sheath is there. Suppose there is a glass rope, so inside will be glass. So it will be a core. Property will come because of the core. Strength, tenacity, anything. But for top side, you can't hold it as glass. So we are putting polyester or cotton. So this sheath. So by taking some certain number of core from Dynama is the nowadays world highest strength fiber. One company in Sandrakas, DCM and Dynama has a lot of things you can see in the websites. So Dynama braid rope, aramid braid rope and polyester braid rope. If we see that naturally Dynama comes on top, aramid comes on bottom and polyester comes on in braiding. But in case of weaving, it will again become more effective and cost effective by even aramid can come on up and Dynama can go down. So cost will be reduced but effect will come more. That way we can do the projects and commercialization. Then if you see this is a Dynama weaving on Dornier rapier loom weaving machine. Now we are talking about carbon very much. I am showing you how carbon fabric is made in Attira. I have some slides of 2013. That time first time it started. So let me show you the video. This. Yeah. This is the manufacture of the carbon fabric. Small spools are coming from a grill and they are making the fabric. Which fabric we are taking for the many uses. This is the carbon fabric actually. This is the raw material for composites. And we are putting resins there, epoxy there, making one piece, then epoxy, another piece, then epoxy, then third piece, epoxy, 50 pieces. So after compression and drying, we can cut it into the bricks and we can make the air space parts or all these things actually. That's why woven carbon is there. Then let me show you the braiding. This is a braiding machine. Braiding is a specialty. For any product we can make it a piece. Or aluminum or other things, kind will come. It will be done. But in braiding, you can make one symmetrical or asymmetrical shape. In most examples, you can analyze Pedro, all this area ID, but also for automobiles, braiding has application. In short, whatever the looking the things are made from the braiding. There are several machines. This is from Germany, a big machine, plus the Attira. They are working there actually. Now, as I told you about braiding, how the concept has come. In Africa, there is a braiding system. This men or women, they are just dressing their hairs more than 3 or more. This is a 5,000-year-old technology taken in a machining form of composites actually, by machine, by Germany and China and all these things. I was in 8 years in Africa actually, for jobs. So these are popular, and breads I have shown you in the video. I will not take much time there. So if we say braiding is popular for manufacturing of industrial ropes, fabrics, and structures for composite application. The braiding process is classified into two-dimensional and three-dimensional braiding. A special advantage of three-dimensional braiding is their ability to develop a variety of symmetrical and non-symmetrical complex shapes. In this way, complex structures shape does not need cutting, joints or splices. As I told you, they are one piece. Then braids are textile constructions which yarn cross each other in diagonal direction. The material used and the size of the yarn can be very versatile depending upon the end application. Now these are the braids. If you see this, sorry. If you see this is a robot actually. Suppose this is a project, final project for braid from glass. Some bobbins are revolving in a clockwise direction, some are wounded in an anti-clockwise direction. So consequently, combination makes the braid, or we can build with the arrangement. Suppose 6 will make able design in clockwise, others 6 will revolve in anti-clockwise, like this. So this braid will come. This braid cannot be offloaded by the men. They are so heavy for aeronautics and automobiles. So there is a robotic technology. This KUKA robot offloaded the braid by programming. It is available actually. I reacted the machine. Then these are the things from aramid. It again depends upon the specification of aramid, what cost we want to do. So they are for sports. Then by braiding, can make bicycle, carbon bicycle, can make formula cards, even such type of for hockey, aramid structures. Then composite can be used to upgrade sports equivalent used to protect athletes or to upgrade the venues that host the games themselves. One of the main reasons for the use of composite is sporting goods is they are low weight. For instance, carbon fiber is at least 4 times lighter than steel. It's more lighter than aluminium. Since composite like carbon fiber are so light, they help improve athletic performance. Glass and carbon reinforced composites also, or in hybrid with other fiber, continue to replace wood and metal in finishing rods. Earlier what was happening, accidentally this cricket bat was breaking and somebody was losing the eye or like this. So now with this type of fibers, it never happens. It cannot happen. And they have the quality standards actually. After passing these quality standards, they are passing this goods for sports or anywhere. So tennis rackets, finishing rods, then shafts, all these things can be made by these composite fibers. The lightweight technology for sport vehicle riders. See what happens, you just imagine a Formula car driver having a conventional helmet, very heavy. He is driving, how he will feel? Or if he has the very lightweight aramid helmet, how comfortable will he feel after 45 minutes of drive? So such type of facilities for athletes with the contribution of composites we are creating. It is happening even on commercial levels. Then motorcycles are there, the helmet same story is there. Then you see the hockey sticks and other balls, made of balls are there. Then you see aramid gloves, aramid glass face guards, because you have to hybrid fiber, aramid Kevlar leg guards, braided aramid sleeves. All the accessories can be made by the composites. Then improved athletic performance, aramid fiber characteristics and bonding properties. Everybody knows, actually I am just skip this slide. Then I wrote a book in 1922. The basis of my work is with Agriculture 3.5 years head of Agriculture Center. So we are just attracting the industry partners, doing the work from them, and everything from right from the raw material to how to make it cost effective, how to prove it in forensic labs, everything we are doing actually. Then we are writing the article also in fiber to fabric fashion and everywhere. So it can be used for everyone in this composite or technical textile industry. Then it gave me inspiration to write a book. So I collected my memory, and based upon that expense, I wrote a book which is available in Amazon and Flipkart. Even the same topic, AMA, I gave a webinar, they are same thing actually. If you put in YouTube, you will get my lecture. So that gives the whole story in details, even more uses in other fields of composite in this book and in this webinar. So please, if you are interested, you can listen it.
That was a wonderful presentation, Mr. Kulshrestha, I must mention, because till this point of time, that is third day, close to half day, we missed the sports part, and he nicely narrated the entire story and all the aspects of sports in such a unique way. So we appreciate your work, sir.
Thank you.
And may I now request Professor Sunil Kale to felicitate Mr. Pradeep for this interesting presentation. And on behalf of Ahmedabad University, sir, I request you to please share the sharings of your book with our students very soon in the near future.
I send the hard copies.